Today topic is about summation of series. The summation of series, as we have done about series. Summation r is equal to 1 to n. This is the symbol for summation. It is called sigma. R is starting from value 1 and going towards value n. Here the value is given. We will put it all the values of this summation and we will get the answer. This is called the summation of series. It means that we will add n lots of 1 together, n lots of 1 together, and our answer will be n, right? So if the series is about 1 plus 2 plus 3 and go on up till n, then we can write it in summation form like that. Summation r is going from 1, which is the first value, and it is going towards the final value, which is n. You can see here, right? So this summation series, we can write it in summation form like that. R is equal to first value 1 to final value n, and we represent all of these numbers by r. So if we want to represent it in summation form, this is the summation form for this series. And if our series is 1 square plus 2 square plus 3 square and it is in square form, then we will write it like that. Summation r is equal to going from 1 towards final value is n, and here we will write r square related to this square, right? R square, and related to this is simple r. And if our value is summation of series is cubic roots, right, then we will represent it by summation r is going from 1 to n, from 1 to n, and it is represented by r cube, right? Now we have to remember the formulas of this. Summation r is equal to 1 to n r. Its general formula is 1 by 2 n into n plus 1. We have to remember these formulas, right? And summation r is equal to 1 to n r square. Its formula is this: 1 by 6 n into n plus 1 and multiply by 2n plus 1, right? And what is the formula of r cube? R is equal to 1 to n r cube. Its formula is 1 by 4 n square into n plus 1 whole square, right? So these three formulas, we have to memorize them, right? And in next question we will do the proof of this formula. This formula r square is equal to summation r square is equal to 1 by 6 n into n plus 1 to n plus 1. We have to prove this, whether this is equal to this. So how can we prove this? We can use the induction method. And what is the induction method? I will tell you what is the induction method. In the induction method, first of all, what we will do, we will take the value n is equal to 1, right, and put the value n is equal to 1 on left hand side and get the answer. And then we will put the value n is equal to 1 on left hand side and we will get the answer. If left hand side answer is equal to right hand side answer, then we will say that it is true for n is equal to 1. Next step, we will proceed further and we will assume that it is also true for the value of n is equal to k. Take k is any arbitrary value, right? You can take any value from 1 to n, right? We will suppose n is equal to k and it's an arbitrary value, and we assume that this statement is true for n is equal to k. This is our assumption. And next we will prove that this statement is true for n is equal to k plus 1. which is the next term of k, right, which we have assumed for previously. So we prove that this statement is true for n is equal to k plus 1. Then after all these things, we will give our final statement that we assume that it is we show that it's true for n is equal to 1. Then we assume that it is also a statement is true for n is equal to k, and then we show that the statement is true for n is equal to k plus 1. This will conclude us to the fact that this statement is true for all n is greater than equal to 1 values. So in this way, this is called the induction method, and by using the induction method we will prove that this statement is equal to this statement, right? And in next we will do its proof by induction method. Now you will see here we have this statement, and we will prove that this statement is true for n is equal to 1, right? Wherever we have n, we will put its value 1. In right hand side I will put n is equal to 1, so I have done it here. Wherever is n, I am putting its value 1, and when I do simplification I get the answer is equal to 1. After that we will go to left hand side, and where is n, we will put n is equal to 1. Then here will be n value is 1, then we will put r is 1 square, right? That is also equal to 1. So this statement is true for n is equal to 1, as we have seen that our right hand side is equal to left hand side. This is the first step for induction method. And what is the induction method is saying that after this we will say that we assume that the given statement is true for n is equal to k. Then statement will take the form wherever is n, I am going to put it equal to k, right? Just so for n is equal to 1, I have proved it in front of you that left hand side is equal to right hand side, and then I assume that it's true for n is equal to k. Then wherever in this given statement we have n, I will put it here, n is equal to k. Just we have done this step. Then we show that it's also true for k plus 1. Wherever we have k, I'm going to put this value k plus 1, right? Wherever is k, I am going to put it k plus 1. This way. Now we have to prove that if it is true for n is equal to k, then it should be true for n is equal to k plus 1. And if we will get this statement, we will show that it's true for n is equal to k plus 1. Now in my left hand side I will write I'm going to divide it into two parts. Like that. What I have done, I put r is equal to 1 to k r square and plus summation r is equal to k plus 1, the final value, right? Because it's going from 1 to k plus 1. First I will put r is equal to 1 to k, and then second is r is equal to k plus 1. Now in this case I can put its value which we have assumed at this one, right? So I will put its value here. It will become 1 by 6 k plus 1 to k plus 1 plus. Now in this case when I will put from k to k plus 1, so the r value will be k plus 1 and we will take its whole square because it is given whole square, right? We will get this statement. Now in next step what I will do, I will take k plus 1 as common because k plus 1 is common in both of terms, right? When I will take 1 by 6 and k plus 1 as common, I have left in first term k and 2k plus 1, and here I have read 6 because I have taken 6 common here, 1k plus 1, right? Because k plus 1 of this k plus 1 is going into common. So in next step what we will do, it will become right. In next step I will show you that we will simply and making the factors of this will be right. Taking 2k as common and I have left k plus 2, and taking 3 as common I have left 3 k plus 2, right? 1 by 6 k plus 1, k plus 2 is common further and I have left 2k plus 3 here. Now I am going to manage this one in such a way, this will be k plus 1 and next will be k plus 1 plus 1 and next will be 2k plus 2 plus 1. You can write it in this way. So we have left 1 by 6 k plus 1 take 2 as common from here, I have left k plus 1 plus 1. Now you can see that it will be very clear that wherever is k, we have k plus 1 here. If you will check the statement, this statement, check it here. Wherever it is k, my answer should be k plus 1. You can see k plus 1, then k plus 1 plus 1. So we have written k plus 1 plus 1, and then next is 2k plus 1. In place of k, we should have k plus 1. So you will check, I have 2k plus 1 plus 1. So I have proved here that this statement is true for n is equal to k plus 1. So at the end we can write that we have shown that if the statement is true for n is equal to k, then it is true for n is equal to k plus 1. Since we have shown it to be true for n is equal to 1, so it must be true for all n is greater than equal to 1. At the end you will write this statement, which is the statement of induction method, that whatever we have done, we have shown that this statement is true for n is equal to 1. Then we assume that this statement is true for n is equal to k. Then we have shown that, we have proved that this statement is also true for n is equal to k plus 1. And as we have shown that this is true for n is equal to 1, then it must be true for all values of n greater than equal to 1. So this is the proof of this formula by induction method, right? Hopefully you can understand it.